Hi everyone, how are you all? Welcome back to my channel and you're watching my channel DNL Learning School. My name is Dhananjay. Last class we discussed about electricity and potential difference, and today's concept will continue with our topic. Our topic is Ohm's law. Okay, so very important children, as far as the exam point of they have asked many times the repeated questions. Okay, so state Ohm's law, derive an expression for it. Okay, all these kind of questions they will be asked in the exam. Okay, what is Ohm's law? The potential difference across the two ends of the conductor is directly proportional to the current flowing through the conductor, provided temperature remain constant. So very important the statement, the potential difference. See the potential difference. What do you mean by potential difference? Voltage. Okay, potential difference means voltage. Voltage is directly proportional to current. So this is a simple Ohm's law. Okay, so what does Ohm's law says? Voltage is directly proportional to current. Okay, so which means it is directly depends on current. What is depends on current? Current depends on voltage. Okay, so voltage is directly proportional to the current. If you increase the current, what happens to the voltage? Voltage also increases. If you decrease the current, what happens to the voltage? Voltage also decreases. So you will come to know that voltage is directly proportional to current. Okay, so consider a circuit here. Consider a circuit that bulb is connected with an ammeter in a series connection and a voltmeter in a parallel connection and a battery. Okay, so you know how does the Ohm's law works here. See, as I already told you, this is a voltage. So electrons will be present here. Okay, so electrons move through the circuit, right? So suppose consider that I have 100 protons here in the positive end. So I have 10 electrons here in the negative end. So what happens? 100 protons. So which means we can say that voltage across these is less. Okay, on that time what happens? Electrons take very less time to travel because they have been pulled with a less amount of force. So when they have been pulled with a less amount of force, they will take more time to travel through the wire. So when the electrons takes more time to travel through the wire, the current produces less. The current produces in the opposite direction. Then the bulb glows in a very dimmer. Okay, so now what happens? Instead of 100 proton, if I keep for 1000 proton or something for the same electrons, now what happens? The potential difference is more. Okay, so when the potential difference is more, it will be pulled with the more amount of force. When it is being pulled with the more amount of force, what happens? Electrons takes very less time to, what happens? Voltage is high, so the bulb glows very brighter. So that's what in a simple word the Ohm's law is. Voltage or potential difference is directly proportional to the current. Okay, so and one more thing they have given. What is that? Temperature remain constant. So temperature remain constant means, what do you mean by that? So temperature remains constant, which means if you are doing an experiment in Bangalore, okay, so you will get a Ohm's law. It can be valid. Suppose if you go to any cold regions like Jammu, Kashmir and all, so you will not get a same value. What is that? Why means because the temperature must be same. So there the temperature varies, you will get a different. So the Ohm's law, it will be applicable, but it is applicable for that instant, that place, and it is applicable for this place. So now voltage is directly proportional to the current. Voltage is directly proportional to the current. So I can say that it is directly dependent. 90% it is equal. So to make it 100% equal, I am going to add one proportionality constant that is called R. So R is called, what is that R? Proportionality constant. Proportionality constant. Okay, so this is always a constant, the proportionality constant. Then V by I is equals to R, which is always constant. Okay, so proportionality constant, that R is called proportionality constant, and then V by I is equals to R, which is always constant. Okay, so what is that R? So that R is, this is an expression for Ohm's law. Okay, so if they ask you the statement Ohm's law, you have to just write this, and if they ask you to derive an expression for this, then you have to just write this. Consider a conductor or a bulb, okay, which is connected in okay, when it is connected with voltmeter and ammeter to a battery, then according to Ohm's law, V is directly proportional to, according to Ohm's law, V is directly proportional to I, and V is equals to Ri, where V by I is equals to R, which is equals to constant. Okay, did you understand? So V by I is equals to R, which is constant. So R is constant. Then what is R? So that R is called resistance. Okay, so R is called resistance. So which means I have already told you, V, if you increase, the current also increases. Okay, so let us take a table. Look at this, V, I, and this is R. So suppose if you have 2 volts of battery, then current will be, you just say that 1 ampere of current is flowing through this. So what if you increase it to 4 volt? I have already told you that if you increase the voltage, driving force will be increases, then what makes the current? Current also will increase. When the current also will increase means 4 volt means it is 2 ampere of current. So what if 6 volt? 6 volt means 3 ampere of current. What if 8 volt? 8 volt means 4 ampere of current. See, for the same, how much ever the voltage if you increase, that much of current will increase. Okay, so now potential difference, right, voltage, right, potential difference, number of protons, that difference is called potential difference. So it drives, it just it pulls the electrons in a very fastly. As it pulls the electrons, what happens, the voltage is more. Okay, so as you increase the voltage, the current also increases. Then V by I is equals to always constant. Now I will do V by I for this. So what is that? So V by I, that is V is 2 by 1, which is equals to 2. Then 4 by 2, which is equals to 2. Then 6 by 3, which is equals to 2. Then 8 by 4, which is equals to 2. This all it remains constant. No, that is called R. That R is called resistance. Okay, so if you increase the voltage, simultaneously current also increases. If you decrease the voltage, current also decreases, but that ratio always remains constant. See here, 2 by 1 is 2, 4 by 2 is 2, 6 by 3 is 2, and 8 by 4 is 2. Okay, so which means something is remaining constant. That remaining constant, that is called R. That R is called resistance. Okay, so then what is the resistance? The opposing force. The opposing force to the flow of electrons. Okay, so the opposing force to the flow of electrons is called resistance. Okay, so opposing force to the flow of electrons. So what do you mean by opposing force to the flow of electrons? See, the wire, whatever the wire is there, it will not let electrons to move through the wire very quickly. Okay, very easily. So it will not let it. So what does it do? It will allow some force. Okay, it will not allow the electrons to move through. It will not stop it either. So what does it do means it will obstruct. So if the electron has to move through very easily means what happens. So suppose you just see that you are running on a road, right? When can you run easily? When there are no people or no vehicles, what you can do? You can run easily, right? But what if more people are walking and all, on that side, road side and all? What happens? Can you run fastly? Yes, no? You will go in a very slow manner, right? Yes or no? So like that. Okay, electrons will move through. So you will run through the street, but still you will not run as easily as there were no people. Okay, like that is a resistance. So what happens? They will not stop you. So what they will do? They will be like that only. So the metals it will not allow the electrons to move through easily. So then what happens? They will oppose you to the flow. Okay, so that is called resistance. Okay, the opposing force to the flow of electrons. So this is only you have to write what is resistance? The opposing force to the flow of electrons. So now the resistance is given by R is equals to, how do you check the resistance? V by I. So when you want to calculate any resistance of a given material, you are going to use the formula R is equals to V by I, where V is called voltage and I is called current. So it's, what is the SI unit? So SI unit is, for V is volt, for current is ampere. Okay, V by A, volt per ampere is the SI unit, or we simply says that we have named after a scientist. It is called ohms. Okay, it's a Greek letter, so we are just representing the resistance. SI unit of resistance is ohm. So we are going to write like this. Did you understand how it is? You have written as a ulta. So this is how the SI unit of resistance. Now you understood that always something remains constant. That something is called a resistance. Okay, so resistance means it's the opposing force to the flow of electrons. Okay, so now we have a device called resistor. Okay, so what is a resistor? What is a resistor? A device of a component of a given size which offers resistance. Okay, so resistance is a force, which that force will be offered by who? That component you are seeing here. Okay, so that component is called resistor. Okay, so resistor is symbolized as like this. So whenever you write like this is a symbol of a resistor. Okay, so what is a resistor? A component of a given size which offers resistance. Note down. So very important. Okay, all these you have to note down, children. So whatever I tell, okay, this are all you can make the keynotes. Okay, resistor. So now, let us, I have taken a one, now here I have a circuit. In this circuit, so now consider a circuit. In this circuit, I have added a resistor. Now I have added a resistor. Now, what makes this circuit? Okay, so electrons will move through the circuit wire. When I add a resistor, this kind of resistor is a fixed resistance. So suppose if it is offering 100 ohm or 1000 ohm or whichever, so that resistance is fixed. So what happens when the electron flows through this? So this is being offered by the opposing force. Okay, so when it is being offered by opposing force, what happens? The electrons moves through this resistance in a very slowly. It takes more amount of time. Because we have added external resistance. Before that, resistance of the wire was there. Now I have added a resistor. So the device only I have added here. That means I am providing external resistance. More resistance I am giving there. Okay, so when I added more amount of resistor, what happens? The electron will flows through it. It takes more amount of time. Why it takes more amount of time? Because this is being opposed. It is not letting the electrons to move through very easily. So we have a current formula, I is equals to Q by T. As the time increases, current decreases. Okay, so now the current decreases, then what happens to the bulb? The bulb glows dimmer. Okay, suppose you have seen so many small bulbs are there, small LED bulbs are given under the they have given below the TV and all. So small chargers and all there. Okay, so you can connect directly to the switchboard. What happens? Okay, when it's connected to the socket, what happens? The more amount of current will flow through. Yes or no? But how can the TV works? How can the charger works for that? Because more amount of resistance is being added. When you added more amount of resistance, what happens? The current in the device will be very less. Okay, when the current in the device is very less, so that the component works. So if there was no resistance, means what would have happened? So you would have plugged in directly, more amount of current flows. When the more amount of current flows, this device would have burned. Yes or no? So this is the permanent resistor. So what is a resistor? A device, a component of a given size which offers resistance. And we have another device is called rheostat. 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 You are seeing here rheostat. Okay, it is like this. So what is the rheostat? What is the symbol of the rheostat? See, I have given resistor symbol is this. Rheostat symbol is like this. You are going to give one arrow mark. So this arrow mark says that we can vary. So this arrow mark also we can say is that we can vary. Okay. So that arrow mark means we can vary. It is not constant. I can just vary how much ever I want. So what is the rheostat? A component of a given size which offers resistance, correct? Rheostat is also resistance, but a device which is used to vary the resistance. So rheostat is also a resistance. It is also a resistor, but it is also called variable resistor. Whereas resistor, the resistance is fixed. But for a rheostat, resistance is not fixed. So, definition for a rheostat is a component which is used to vary, VARY, which is used to vary resistance in a given circuit. Okay, you want to vary the resistance in a given circuit. Okay, so that components we call it as a rheostat or a variable resistor. Okay, variable resistor also same and rheostat also same. Okay, so which we can vary the resistance, which means we can increase the resistance or decrease the resistance. So instead of this symbol, so now what I will do, I will put the symbol like this. So arrow mark, which means I can increase the resistance and also I can decrease the resistance. Okay, so now what happens? Now when the electron flows through this, so if I just vary the resistance, what happens? If the resistance is more, then what is the brightness of the bulb? Dimmer. It will be dimmer because resistance is more. Then I will vary the resistor. Then I will keep the resistance less. What happens to the brightness of the bulb? Brightness of the bulb will be more. So we can vary the resistance in a given circuit. We are going to use a device called rheostat or variable resistor. Okay, so next we didn't define one ohm here. So what is 1 ohm? When the current flows, when the voltage across the conductor is 1 volt, when the current flows through 1 ampere, we say that the 1 ohm resistance. When do we say 1 ohm? See, all these are all very important. 1 ampere, 1 ohm, 1 volt. Okay, they will ask frequently, they will ask define the unit of potential difference, means 1 volt you have to define the unit of resistance, means 1 ohm you have to define the unit of potential difference, means 1 volt you have to define. Okay, so these are all about the Ohm's law. And another 2 more devices are there. So one is conductor, another one is insulator. Okay, what is a conductor? A component of a given size which offers a less resistance, very less resistance is called as a conductor. Note down, what is a conductor? A component of a given size which offers less resistance. What is an insulator? The component of a given size which offers more resistance is called as insulator. So main four things we have to know, that is what is resistor, rheostat, conductor and insulator. So next we have differences between ohmic devices and non-ohmic devices. What are ohmic devices and non-ohmic devices? So ohmic devices are the devices which obeys Ohm's law, okay, which always V by I is always a constant whichever you take, okay. So that V by I, if it gets always a constant, then we call such devices as ohmic devices. Okay, so which are non-ohmic devices? The devices which does not obey Ohm's law are called non-ohmic devices. And the next difference is resistance is always constant for ohmic devices. Okay, resistance wherever you take, just take. So if you increase the voltage, you know, the resistance of the system always remains constant. So but what about the non-ohmic devices? The resistance is not constant. Resistance is not constant. And the third one is VI graph. Okay, so for a VI, so for voltage versus current, we are going to draw a graph. That such graphs are called VI graph. VI graph is a straight line passing through origin. So it passes through straight line. It passes straight line through origin. This is called origin. It is a straight line. Okay. So but what about for this? It is a curved graph. It is curved graph, which means if you are increasing the voltage, current remains the same. So for example, see here, I have some 3 volt, the current is, you just say that 4 ampere. So now increase to 6 volt, the current is, you say some 6 ampere. Now we are increasing the voltage. You are increasing the voltage 15 volt. We are increasing the current, but the current remains the same. Okay, so even though if you are increasing the current, the voltage, the current is not increasing. So such this curved graph you will get, and usually all metals obeys Ohm's law, and transistors and diodes do not obey Ohm's law. So this is about the differences between ohmic and non-ohmic devices. Okay, so the next one, how to calculate the resistance from graph. So how to calculate? To calculate, very important children. So they have given one exercise question also for you. To calculate resistance from graph. Now we are come to how to calculate resistance from graph. Okay, see children, sometimes they will only give you the graph and sometimes they will ask you to draw the graph. So it depends on the the graph. So now I have taken a 2 axis. So let us say this is x axis. Okay, so x axis I have taken current, that is in ampere. So whatever the numbers I have written, all you should read it as an ampere, 1 ampere, 2 ampere, 3 ampere, like that. And whatever I have taken here, it is in voltage. So voltage is taken on y-axis and that unit is volt. Okay, so now you can see here one, in your graph books and all, you will have one box, right? So that box is a measurement of 1 centimeter. So now here how much I have taken, one box. So this is scale, I have to write scale on x-axis. Okay, on x-axis I have taken one box. So 1 centimeter means 1 ampere, children. 1 centimeter means you have to consider the 1 ampere. On y-axis, okay, on y-axis 1 centimeter means you can see 2 I have taken, so which means 2 volt. Okay, like this you have to take the scale. Now so example, I got a graph like this. How do I get? See, for example, first I will get the points like this. So 1 point like this, 1 point like this, 1 point like this, 1 point like this. Now what I will do means I will take a scale and I'll join all these points. Minimum three points must be coincide. Now how to find the resistance from the graph? So to find the resistance, you have to take any 2 points, children, any 2 points from the graph, or any you can, your wish, you can take anywhere you draw a right angle triangle, that's all. Okay, now I have taken a points, 2 points here. Now we will draw a right angle triangle like this. So let us mark this as A, let us mark this as B, and let us mark this as C. Okay, so now how do you find the resistance? By finding the slope, we can able to find the resistance. What do you mean by slope, children? Slope is nothing but AB by BC is called slope. Okay, so if you draw any kind of graphs, so if you find slope, that will give you the characteristics of the, what the experiment we are going to do. Okay, like that, if you want to find the resistance, you will do so many multiple of experiments. You want to calculate the resistance. How do you calculate? By calculating the slope. The slope is AB by BC. Okay, so that is equals to slope. Now AB length you want to find. So see here, AB length how much? 4 to 6. Okay, how much is there in between that? So 2 volt is there. Okay, so 2 volt into how many centimeters, children? 1 centimeter. Okay, which is nothing but, no problem, I have taken as a 2 volt. Okay, 1 centimeter divided by, so how much is BC? BC is between 2 and 3. How much is 1 ampere? 1 ampere. So what is 2 by 1? 2 by 1 is 2. 2 ohm is the resistance. Okay, so then R is equals to 2 ohm. This is how you should able to find the resistance from the graph. Or if they ask you to draw the graph, you just take whichever the scale, children, you want. So you can take, so is there any rule that I have to take only this many? No, you can draw a big triangle also, we can take. Okay, but you have to count how many boxes? 1, 2, 3, 4, 5. Suppose I have taken from here to here. Then how much is the voltage? 1, 2, 3. 3 boxes are there. Okay, 2 volt into 3, 3 centimeter. Because I have taken 1, 2, 3. So 1, 2, 3. 2 volt into each is 2 volt. 2 volt into 3 centimeter by. So from here to here 1, 2, 3. 3 ampere into 3 centimeter. Okay. So centimeter cancels anyway. 2 3 is a 6 volt by 3 3 is a, sorry 3 into, not 3 centimeter, it is 1 centimeter, because 1, 2, 3, these are all 1 centimeter now. So here it is 3 centimeter, because 1, 2, 3, 3 centimeter. Here each is 1 ampere. So this is 1 ampere. 1 ampere. So 1 ampere into 3 centimeter. This is 1 ampere. 1 into 3 centimeter. Here 2 into 3 centimeter. So 2 3 is a 6, 1 3 is a 3 ampere. So now when you calculate, you will get 2 ohm. 3 1s are 3 2s. Volt by ampere is what? Resistance. Okay. So you can take any graph, children, any slope, you will get the correct answer like this. Okay.